I'm going to solve a couple of optimization problems here. These are problems just involving numbers. One thing here, I have a correction in the second problem. I want to say two positive numbers, x and y. So the first problem here, find two numbers whose difference is 150 and whose product is a minimum. Now, when I'm looking at an optimization problem, there's typically a goal, something I'm trying to minimize or maximize, some quantity. And what I see here then is we're saying whose product is a minimum. So that means I'm trying to minimize the product. Product is a multiplication problem, so I'm going to multiply two numbers together. I might want to indicate how I'm representing those numbers. So what I can look at here, I can say, okay, what are my two numbers going to be? My numbers maybe are going to be x and y. And what I'm trying to do then is I'm trying to minimize this quantity. I can call it q, which is going to be x times y. Now, to minimize a quantity, I'm going to want to take the derivative of q, q prime, and set it equal to 0 or find out where it's undefined. The problem here is q has two variables involved, so we can only take the derivative if we have one variable. So what I need to do is I need to look back at this problem and say, is there some other information in this problem that would allow me to relate x and y together so that I can solve for one in terms of the other? And of course, we've got that information there that the difference is 150. Now remember, a difference is a subtraction problem. So what we're given here is that if I take and subtract the numbers x minus y, I get 150. Now you could wonder, why did I take x minus y and not y minus x? How do I know x is bigger? Well, I don't really, but however we set it up, we're going to solve and get a number for x, and then we'll substitute and get the other number for y. No matter which way I set up this constraint, basically, that x minus y has to be 150, if I set it up the other way, I'll get the same two numbers at the end, I'll just get them in a different order, and that doesn't really matter. So I need to solve this equation for one of the variables. It's probably going to be easiest to solve for x. I'll just add y to both sides. So if I do that, I get x equals y plus 150. Now I can go back to this function q. Q is supposed to be x times y, but now I'm just going to replace x with y plus 150. And then I'll go ahead and distribute, and I get q is y squared plus 150y. And that's essentially the setup to the problem. What I'm trying to do now, I'm trying to minimize this function q, which we've said now we've rewritten as y squared plus 150 times y. To minimize, I want to take the derivative q prime. So I bring down the 2. The derivative of 150y is just 150. And then I'm going to set that derivative either equal to 0 or see where it's undefined. Well, this is just a nice linear function. It's never going to be undefined. So I'm going to solve here, subtract 150, divide by 2, and I get y equals negative 75. That's one of my numbers. To find my other number, I'm going to look back here to what we've got right there. X is y plus 150. So we've got y is negative 75. So that's going to tell me x has to be positive 75. The only other thing we sort of have to check out here is, do I really have a minimum? And remember, a minimum occurs when I have a function that changes from decreasing to increasing, right? The function has to be going down and then turn around and come back up, and at the bottom of that is where we would have a minimum, right? So I need to look at this function and decide, okay, do I really have a minimum here? I'm looking at y values. I found my critical number at y equals negative 75. So I need to check my derivative a little bit on either side of negative 75. So if I go down 5, Negative 75 minus 5 would be negative 80. What happens if I plug negative 80 into this derivative? I would get 2 times y, 2 times negative 80. That's negative 160 plus 150. That's going to be negative 10. And so my function is decreasing at y equals negative 80. On the other hand, if I take this negative 75 and I add 5, that gives me negative 70. So if I plug in negative 70, well, 2 times negative 70 is negative 140 plus 150. That ends up being positive 10. And so my function would be increasing at negative 70. So at negative 80, it's decreasing. At negative 70, it's increasing. Negative 75 was that critical number in between, so it would have this shape. It's decreasing, hits negative 75, and then is increasing. So I really do have a minimum, and so I can say the minimum product occurs when the numbers are x and y, 75 and negative 75. Okay. Now, when I look at the next problem, find two positive numbers x and y whose product is 20 such that x plus 5y is a minimum. I'm already saying we're going to use x and y for the numbers. What we're trying to do is we're trying to minimize this quantity here, and so I'm going to minimize my function q, which is x plus 5y. Like before, the problem is my function q here is described in terms of two variables, so I can't take its derivative yet. So I look for other information in the problem I'm not using, and I'm not using the fact here that the product is 20. So I'm not given a difference like I was in the first problem. Here I'm given a product. Their multiplication result is 20. So I know that x times y equals 20. And then I'm going to solve for one of those variables. It's pretty easy to solve for either one. If I solve for y, I get y equals 20 over x. What I could do then is substitute that back into q. So q is x plus 5y. So I replace y with 20 over x. So that's 5 over 1, so I get 100 over x. And if I rewrite that with a negative exponent, we get x plus 100 x to the negative 1. So my goal here is to minimize q equals x plus 5y. Oh wait, no, what did I call that? X plus 100, x to the negative 1. That's how I rewrote it down here, right? So that's what I want to use for my q. I can rewrite that a little bit, so maybe I should just left it x plus, no, I want to take q prime. Okay, so let's take q prime. Q prime, the derivative of x is just 1. Here I bring the negative down, so it becomes negative 100. I subtract 1. Negative 1 minus 1 gives me negative 2. So if I look at this then, that's going to be over x squared. So if I write this as a single expression, a single fraction, I get x squared minus 100 all over x squared. So if I'm going to look for critical numbers here, critical numbers are where the derivative is either equal to 0 or undefined. So if I set q prime equal to 0, well, q prime here is this fraction. For a fraction to be equal to 0, that means the numerator has to be 0. So if I take the square root, I would get plus or minus 10. But my requirement up here is that we have two positive numbers. So this negative isn't really an option. So I really just get x equals 10 is a critical number that I'm going to have to check. I also could have q prime of x undefined. But for a fraction to be undefined, that means the bottom would have to be 0. So that would lead, I take the square root of 0 is still 0. The problem with that is if I let x equal 0, then when I'm going to go and find y has to be 20 over x. 20 over 0 would be undefined. And so this solution, this critical number, is not applicable to solving this underlying problem. It is a critical number, but it's not going to allow me to find these two numbers. So I've found my value for x. How do I find y? Well, y is 20 over x. We've got that x is 10. So that tells me that y will be 2. Do I really know that this is a minimum? Well, I'm looking here. This is my critical number. So I need to look at the derivative on either side of that critical number. So what happens if I look at q prime of 9? If I plug 9 in for x for my q prime, right here, I get 81, 9 squared, 81 minus 100. So I get negative 19 in the top. And in the bottom, 9 squared gives me 81. So that's negative, so it would be decreasing. And if I look a little bit on the other side of 10, I'd plug in 11. And if I plug in 11, I get 11 squared minus 100. 11 squared is 121. So when I subtract, I'm going to get 21 over 121. That's a positive number, so that will be increasing. So my function is changing from decreasing to increasing. That means I would have a minimum there at the bottom, which is what I want. So the minimum occurs when we found x equals 10 and y equals 2.